So with our last video, we started to talk about tissues in the body, and I mentioned that there are four main tissue types: epithelial tissues, which we've looked at, muscle tissue, nervous tissue, and the fourth main category is the one that we're going to talk about today, and that's connective tissue. So this is one of the most common types of tissue in the body, and basically you find it anywhere that you have body parts that need to be connected together. There's a few things about connective tissue just generally that you should know about before we start talking about some of the specific types of connective tissue. And probably the biggest thing is just a little bit about its structure. Connective tissues are kind of strange in that all of them have a living component and actually a non-living component in the tissue as well. So if you look at the list that I've got here on this slide, I've got listed under non-living, ground substance, and fibers. And we're going to talk about those a little bit more. And then the living components of connective tissues are the cells. So I want to start out, I think, with the fibers first of all, because they are quite easy to see on this diagram. So if you look at this diagram over here, this artist representation of the connective tissue, you'll notice that we've got these long, kind of stringy fibers that are actually kind of running or scattered through the tissue. So this first one that I'm running my little finger along here is what's known as a collagenous fiber. These fibers are the biggest fibers that you find in connective tissue. They're made out of a protein which is known as collagen, and collagen is incredibly strong. So it's actually stronger than steel of the same size. Because it's so strong, when you find collagen in connective tissues, it tends to make those connective tissues really strong and really capable of binding structures together in the body. The second type of fiber that I want to mention is what's known as elastic fiber. So again, if you look at this diagram, you'll notice that we have these thinner fibers that are represented in orange that again are kind of interspersed throughout this tissue, and these are the elastic fibers. As their name implies, they are really stretchy. So when you have elastic fibers, they tend to give a quality to the tissue that they're found in of being very stretchy. Elastic fiber are made out of a different protein than collagenous fibers. The protein that they're made out of is actually known as elastin. The last type of tissue that I want to mention is what's known as a reticular fiber. So you can see kind of this thin blue line that's kind of scattered in the background here. These are reticular fibers, so they are also made out of collagen. However, it's a different form of collagen than what we see with the collagenous fibers. Reticular fibers provide a scaffolding for tissues, if they will. So they kind of help to give the tissue some support and some scaffolding. So those are the fibers. We've also got, this is the only living component of connective tissues, cells that are kind of interspersed throughout it. So if you look at these different cells in here, you'll notice they're of different shapes, they're of different sizes, and the reason for that is that they are different kinds of cells. So some connective tissues, like the one we're looking at right now, have many different kinds of cells within them. Other connective tissues, such as fat, which is a connective tissue, has really just predominantly a single cell type. But the cells make up the only living component of connective tissues. What I want to do now is actually come back to this number one, okay, this third component that you see with connective tissues that's non-living, which is known as ground substance. So if you look at this diagram here, we've talked about the fibers, we've talked about the cells. The ground substance is that blue stuff that you can see filling the space in between all of the fibers and all of the cells. In most connective tissues, it's kind of a gelatinous jelly-like fluid. It's non-living, so it's just there. It's kind of filling that space. It provides some cushioning in a lot of connective tissues, and it has some other roles in connective tissues, which you'll learn about in the activity that you do in this folder. So now that we've talked a little bit about connective tissues in general, kind of what they do in the body and their basic structure, what I want to do is talk about how connective tissues are organized. I mentioned that this is one of the most common tissue types in the body, and that there are a lot of different kinds of connective tissues. There are so many. I've got some of them listed here. that we actually classify them into subcategories. So I want to talk about each of these subcategories of connective tissue, starting with connective tissue proper. So connective tissue proper is probably our biggest category of connective tissue. It contains the most difference of connective tissue in it. But a connective tissue is considered to be connective tissue proper when it has fibers that are visible and also has a ground substance that is a jelly-like fluid. These other types of connective tissue, so these are our other categories that are not connective tissue proper, cartilage, bone, and blood. There's something about the matrix. So the matrix is the fibers and the ground substance that's weird, that makes it so they cannot be classified as connective tissue proper. So anytime we're talking about a connective tissue that's connective tissue proper, again, it means it's got fibers that are present and it's got a ground substance that is kind of a gelatinous fluid. So the first type of connective tissue proper is what's known as loose connective tissue. And you can see I've got 3 examples of loose connective tissue represented here. Its name implies this is a connective tissue that's more open, that's more airy. If you look at this picture down here, this is actually areolar connective tissue. So this is a type of loose connective tissue. You can see the cells that are kind of interspersed throughout there. You can definitely see the collagenous fibers. There's some elastic fibers in there as well, and actually some kind of squiggly reticular fibers in the background. But you'll notice as you look at that tissue that there's lots of open space that's filled with the ground substance. It isn't just fibers and cells that are kind of compacted in there, but there's a lot of open space. These loose connective tissues, because they have that open space that's filled with a jelly-like ground substance, tend to be really good at cushioning, and you'll find them in areas of the body often that need cushioning. Adipose is fat, so that's another example of a loose connective tissue, and it is the cushion for our body to help protect underlying structures in our body. The second type of connective tissue proper is what's known as dense connective tissue. So dense connective tissue is the opposite of loose. When you have a dense connective tissue, you have so many cells and so many fibers compacted into the area that there's really no visible open space. Instead, the tissue really just kind of looks like a solid because it's so very, very dense. Dense regular and dense irregular, you'll have a chance to learn about in the activity that you're doing with this folder. But the basic difference between the two is with dense regular, you've got collagen fibers that are organized in a very regular pattern, just kind of stacked one on top of another. Dense irregular has collagen fibers that are kind of running in all different directions throughout that particular tissue type. But in both cases, again, we've got lots of fibers and cells. We've got lots of the solid components of the tissue and very, very little of the ground substance present. So it makes a much denser tissue. What I want to do now is come over here and talk about some of these other categories of connective tissues. I mentioned previously that these are not connective tissue proper because there's something that's weird about the matrix. So remember, that's the ground substance and the fibers that make up the matrix. The first type of connective tissue that fits into this other category is cartilage, and I've got a few different examples of cartilage connective tissue listed under it. If you look at this picture down here, this is cartilage, and as you're looking at it, you'll notice there is no open space. You can definitely see the cells, so these little kind of white things are the cells, and then you'll notice maybe you can see some fibers. There's kind of a streak through there that's a fiber. But all of these other areas that would normally be open and airy, if this was a loose connective tissue, are kind of filled in, they're hardened, they're dense. And that's because what's weird about cartilage as far as its matrix is the ground substance is hardened into a solid. It's not a jelly-like fluid like we see in connective tissue proper. And that's the reason that cartilage is kind of off in its own category, because it's got that weird situation with its matrix being a solid. Bone is actually the exact same thing. So bone is a connective tissue. There are little cells embedded throughout bone. There's fibers that are present in bone, believe it or not, that help to give bone some elasticity. but what we typically think of as a bone is actually just the hardened matrix of the bone. So this is why bone is also not a connective tissue proper, because its ground substance is hardened into a solid that makes up the bulk of the bone. Blood is one last connective tissue type. So if you think about most of these other connective tissues that we've talked about, they're physically binding structures together in the body. Blood doesn't physically bind things together, but it is a communication pathway. So cells can release chemicals, oxygen gets into the blood, and the blood acts as a communication pathway to kind of transport those things to all the cells of the body. So it's linking the cells of the body together through chemical means, through communication means, if you will, as opposed to a physical connection between structures. So blood is also an other. It's not a connective tissue proper. And the reason for that is it has a fluid matrix or a fluid ground substance, and it has cells that are located within it. But under normal circumstances, blood has no fibers. And that's really important, actually, because if blood had fibers within it, it would interfere with the blood's ability to flow. When blood clots, so if you have a cut and your blood clots, what happens is you get some fibers actually forming within the area of that injury within the blood that helps to stop the blood flow in that area. And that's the only time that blood actually has fibers. So again, it's got something that's a little bit off about its matrix in that it doesn't normally have fibers unless it's clotting, and that's why it is in this other category and not a connective tissue proper.